Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of InnoEnergy. Biomass is expected to play an important role in the coming future in the transition to a low-carbon economy. However, not everybody agrees. What is the problem? And why is it a problem? In this video, we analyze the key problems or the potential risks, as well as how to assess the environmental impact. All our activities have an impact in the environment. Producing and consuming energy is one of them. Consuming energy for heating, producing electricity, or transportation can have a negative impact in the environment. However, not all the energy resources and technologies have the same impact. What is the impact of using biomass for energy? What are the advantages and drawbacks when compared with other sources of energy like the fossil fuels? Promoting biomass as an alternative can have some advantages, mainly when replacing fossil fuels. However, there are some risks. When promoting biomass for energy, some practices can lead to a negative result in such a way that the environmental impact can be worse than other alternatives. Policymakers and practitioners must take into account these risks when designing strategies and proposing solutions. Let's take a look at some of these risks. CO2 emissions. One of the advantages of bioenergy can be the net saving in the emission of CO2 to the atmosphere. However, this feature depends on how biofuels are produced from the natural resources. An increased demand for forest-based biomass may lead to minimal or even negative greenhouse gas savings compared with fossil fuels. The adoption of sustainability schemas for the production of forest biomass can mitigate this risk. Bioenergy can also lead to adverse environmental impacts on biodiversity, soil, and air quality. Therefore, sustainability schemas should not focus only on the regrowth of trees, but in a holistic approach to the environmental consequences. Biomass utilization can increase the pressure on natural resources. For example, the combustion of large volumes of biomass in low-efficiency installations, driven by public support, can create additional pressure on resources, in particular in the case of electricity-only plants. For example, the greed of some companies can lead to the selling of biofuels on the basis of a fake sustainability certificate, so they cannot be considered sustainable. Therefore, public policies must be carefully designed to avoid bad practices driven by the support given to bioenergy. Increased administrative burden and related costs for operators. Having different binding sustainability requirements across EU member states leads to increased administrative burden and related costs for operators. Therefore, sustainability schemes must be adopted at regional level. After analysis some of the risks of bioenergy, let's analyze its environmental impact. The analysis of the impact of bioenergy is complex and can vary significantly because it depends on many factors. The analysis of the impact should focus on the biomass supply chain, which includes all the steps, from harvesting of bioresources to the production of heat and power. The analysis of the supply chain must be addressed from a life cycle perspective. The calculation of emissions should include all the impacts for the production and delivering of biomass fuels. The change in the land use, cultivation, transport, and processing, as well as biogenic CO2 emissions, which include the emissions from combustion of the biomass source and the CO2 absorbed due to plant regrowth. When analyzing the greenhouse gas savings compared to reference fossil fuel emissions, main results show that wood chips, in general, have more savings than wood pellets. Savings are higher for the production of heat than for the production of electricity. The reduction of GHG emissions decreases for long transportation distances. However, transportation has a slight impact for wood pellets. Savings also depend on the origin of biomass. For instance, for wood chips the highest savings are for wood industry residues, and the lower savings for short rotation coppice like poplar or eucalyptus. Life cycle assessment, or LCA, has emerged as the main tool used to inform policymakers about potential environmental impacts of products and policies. One of the key points to be analyzed is the use of land. Biofuels made from waste biomass or from forestry have very little effect. However, converting rainforests, peatlands, savannas, or grasslands to produce crop-based biofuels have a strong influence in the use of land. Let's analyze this point in detail. The carbon debt of bioenergy is the difference between savings in the emission of GHG by replacing fossil fuels and the GHG emitted because the change in the user of land. For example, by converting rainforest to produce palm oil and biodiesel in Southeast Asia. Direct change of land use refers to the cultivation of dedicated energy crops in the land under study. Indirect change of land use appears when a change is induced in another geographical region. For example, when biofuels are produced on existing agricultural land, the demand for food and feed crops remains, and may lead to someone producing more food and feed somewhere else. This can imply changing forest into agricultural land, which implies that a substantial amount of CO2 emissions are released into the atmosphere. But the conversion of land from its original use to the cultivation of biomass for bioenergy not always produces more carbon emissions. In some cases, it can result in carbon sequestration. For example, when abandoned or degraded agricultural lands are used to grow energy crops. There are many other environmental issues that can be included in the LCA, for example, plants absorb minerals that are extracted from the soil when biofuels are produced. This elimination of minerals from the soils can cause the loss of fertility in them. Utilization of ash and separation of heavy metals. When burned, biomass leaves behind ash, which can contain heavy metals. Its management must be taken into account in the LCA. Opportunities to treat municipal waste. The treatment of municipal solid waste in biomass facilities also influences the overall environmental impact. The cultivation of trees and plants and their subsequent harvesting modifies the resistance of the soil to erosion caused by rain and wind. Modification of the local ecosystem due to biomass harvesting can have an impact on biodiversity. Inefficient biomass burning in low-income households leads to indoor air pollution, leading to illness and premature death. Biomass projects can have a positive impact on alleviating poverty in developing countries. Soil fertility and productivity change when plants are grown to produce biomass due to multiple factors. Irrigation of energy crops causes an increase in water consumption that can have a negative impact on other water uses. The use of fertilizers, herbicides, and pesticides in energy crops has a negative effect on the environment. The production, processing, and end use of biomass produces not only CO2 emissions, but also other air and water pollutants. Some energy crops are based on genetically modified organisms, which has an impact on the ecosystem. Wrapping up, the utilization of biomass for energy can have positive or negative impacts, depending on the processes involved in the supply chain. The life cycle analysis is the most powerful tool to deeply analyze this impact. Policymakers and engineers must take decision to foster benefits and to avoid undesirable consequences.